All right. Hi, everybody. So this is Mrs. Power. We're going to give this a try again. So I'm doing the 4.3 notes for right triangle trig. This is a review of geometry and probably algebra 2 as well. So we're going to start out with reviewing the Pythagorean theorem, which obviously, hopefully you remember, is a squared plus b squared equals c squared. And that is assuming that a and b are the two legs of a right triangle and c is the hypotenuse. So if we wanted to find any of those sides and we had two of them, we could do Pythagorean theorem and solve for any one missing side. The other ones is we're going to review trig functions. And so for those, I remind people that you were using the phrase SOHCAHTOA, and I'm going to write it down the side here. And the reason I'm writing it vertically instead of horizontally is so that you can see that if it's a sine problem, you're going to do opposite over hypotenuse. If it's a cosine problem, you're going to do adjacent over hypotenuse. And if it's a tangent, you're going to do opposite over adjacent. So for those letters, it really depends on where you're standing on the triangle. We're never going to stand at the right angle. We're always going to be standing at one of the other acute angles, and we're going to call that position theta for now. So if I'm standing there, then my feet are standing on two sides of the triangle. They're going to be standing on the hypotenuse, that is the side opposite the right angle, and they're going to be standing on the adjacent side, that is the side that my other foot would be on. And then I'd have to travel all the way across the triangle to get to the opposite side. So if I was trying to do sine of this using the little green A, B's, and C's, I would write I'm looking for O over H, which would be A over C. If I'm looking for cosine, it's A over H. And in the green colors, A over H would be B and C. And if I am looking for tangent, it would be O over A, and that would be A over B. Okay, so cosecant. Notice that when it starts with sine, its reciprocal function is going to start with a C instead. So there's a first letter switch. Okay, so cosecant is going to be the exact flip. So the exact flip would be H over O, which would be the same thing as C over A. Secant would be the flip of cosine. Notice again those first letters switch. And so this one would be C over B. And tangent would be cotangent. And that one would be B over A. So again, same thing there. They're just considered reciprocal functions. So this is H over A just flipped upside down. This is A over O just flipped upside down. Okay, so if I want to find the values in example 1 of the 6 trig functions, we are looking at this triangle here. It's only got two sides though. So see how they put a theta symbol right here? We're going to do all of our side measurements or our side names based on if I'm standing right there by the angle. So remember, my 2 feet are always going to stand on adjacent and hypotenuse. And if I go all the way across, I'll get opposite. But what I notice is that I am missing some measurements. I've got an 8 here and a 6 here. So I'm going to have to use Pythagorean theorem to figure out what this side is. So since those are two legs, we're doing 6 squared plus 8 squared equals c squared. That's going to be 36 plus 64 equals c squared. So c squared is 100. That means this side must be the square root of 100 to get down to c, or 10. All right, so once I have that, then I can set up all the trig functions as if I'm standing at theta. So we do sine first. So sine, if I'm standing at theta, is going to be O over H. And in this case, it's going to be 6 over 10. And if I reduce that, I get 3 over 5. Cosine, if I stand at theta, is going to be A over H, which is going to be 8 over 10, which is going to reduce to 4 over 5. And tangent, if I'm standing there, is going to be O over A, which is 6 over 8, which is 3 over 4. Notice if I write them in this order every time, you can see that sine is a 6, cosine is an 8, and a tangent are those two numbers stacked on top of each other. So it makes it a little bit easier to organize your numbers when you're writing them in order. Okay, so the reciprocal function, since that is sine, I need the ugly one that starts with a C, so that's cosecant. And I'm just going to take their last answer and flip it. So I'm going to call it 5 over 3. This one is going to be secant. Notice it starts with a cosine, so it's the weird one that starts with an S. This one is going to be 5 over 4. And then cotangent is going to be 4 over 3. All right, so we've got that part done. Now let's go find all the missing sides. Now these are two really special triangles, and the reason is because 45s come from a very perfect polygon called a square. So if you put a diagonal onto a square, you get a 45-45 triangle. So what I know about a square is if this side is a 1, the other side is a 1 as well. So this also has to be a 45-degree angle. Since triangles only add up to 180, we've already used 90 and 45. That only leaves us 45 left. And sides opposite their angles that are alike have to be the same as well. Okay, so how do I figure out what this hypotenuse is? So we're going to again use Pythagorean theorem. So we're going to be doing 1 squared plus 1 squared. Those are the two legs, equals c squared. So I'm going to get 1 plus 1 equals c squared. So 2 equals c squared, so c must be square root of 2. So this is going to be a square root of 2. So this is going to be a triangle that we see quite a bit because of it being such a special triangle. And you'll see that later as we continue on in the trig, or if you remember it from Algebra 2, you know that's true as well. So if I'm going to go ahead and I'm going to do the trig functions for this, I have to decide where I'm standing. Well, it doesn't really matter because no matter which angle I'm standing at a 45. So if I'm standing at this one, then the order that I want to write this in is going to be sine of the angle I'm at, 45 degrees, is O over H. So if I'm standing here, this side is O, this side is H. So we have 1 over square root of 2. And of course, to fix that, because we still don't like square roots on the bottom, that's going to be square root of 2 over 2. Cosine of 45 degrees is going to be adjacent over hypotenuse. It is also 1 over square root of 2, so it is also going to turn into square root of 2 over 2. Okay, and then tangent of 45 is going to be O over A. O over A is 1 over 1. That's equal to 1. Okay, so if I switch then over and I do the reciprocals for all 6, then this one is going to be cosecant at 45 degrees. Now, if I flip this last answer over, I'm going to have to simplify it again. So I'm going to go all the way back to here and just flip this one, and I just get radical 2 over 1, or radical 2. Same thing with cosine, it's going to be secant of 45. And if I just flip that one over, I'm going to get radical 2 over 1. And then tangent of 45, if I flip a 1 over a 1, it's still going to be a 1. Okay? All right, the other thing we kind of want you to remember, and we'll come back to this later, is 45s are special. They always have the same relationships to each other. And that is, if you always start with the smallest side, I'm going to call it x and circle it, then we know the other side also has to be an x because it's an isosceles right triangle. And we also know that to get over to this other side, it's always going to be multiplied by radical 2. So that means I could use Pythagorean theorem if I get stuck, but at some point it would be nice to kind of know that these are the main formats for a 45-45. And if you follow the arrow, you're always multiplying. Let's say they gave you the hypotenuse and you were trying to find one of the sides, and that's all they gave you is the hypotenuse. Well, then you would go against the arrow and you would divide to go backwards. Okay, so you would go this way, you would be dividing by square root of 2. All right, so let's go on to the last one, which is a 30, 60, 90. So obviously the 60 and the 90 are there, so this one has to be the 30 up here. I'm going to stand wherever they told me to, which is right here. Usually you stand on whatever angle they give you first. So if I do that, my 2 feet are on hypotenuse and adjacent, and the opposite side is all the way across. Now on this one, I only am given a 1. So to figure out this one, we're going to kind of look at this in a slightly different way here. We are going to, I'm just looking to see where this all went. Yes, we're good. Okay, so we're going to look at where this actually came from. So I'm going to recopy this triangle right here. Remember, the 30 is up here, the 60 is down here. And again, this comes from another perfect shape, which is an isosceles triangle. So if there was another 30 up here and another 60 down here, you could see that this is an equilateral and an equal angular triangle. So if this side was a 1, then this side is a 1 of an equal angular equilateral triangle. That means that this entire side is a 2, this side is a 2, this side is a 2. Okay, so now I could use Pythagorean theorem to come back and find that height of the triangle right here. And if I do that, I will get 1 squared plus b squared equals 2 squared. So I'll get b squared is 4 minus 1, so b is square root of 3. Okay, so that means if I take this all the way back up here again, this has to be a 2, this has to be a 1, this has to be a square root of 3. So the main patterns for this one are, again, it'd be nice to know your smallest side first. Then when you go to the hypotenuse, it's always going to be a multiply by 2. And if you take your smallest side and you go towards the side opposite the 60 or the opposite side, it's always going to be multiply by radical 3. So you're always going to start with whatever the smallest side is. So if the smallest side was 7, your hypotenuse would be times 2, 14, and your opposite side would be 7 times radical 3 or 7 radical 3. All right, so continuing on, let's go ahead and write down our trig functions from here. So I'm going to be doing it from 60. So sine of 60 is going to be opposite over hypotenuse. So that is radical 3 over 2. Cosine at 60 is going to be a over h, that's 1/2. Tangent at 60 is going to be o over a, which is radical 3 over 1. Okay, so if I flip these, this is cosecant of 60 is going to be 2 over radical 3, so I'm going to have to fix that. So I'm going to get 2 radical 3 over 3. Secant at 60 is going to be 2, just flip it upside down. And cotangent at 60 is going to be 1 over radical 3. We'll have to fix that one as well, and we'll get radical 3 over 3. All right, so there we go. We've got all of those. All right, before we switch over to the other page, I want you to notice something here, and that is I decided to stand at the 60-degree mark, okay? So had I decided to stand at the 30-degree mark, would sine of 30 be the same as sine of 60? Would sine of 30 be the same as sine of 60? Well, sine of 30, if I'm standing up here, sine of 30 would be O over H. And if I'm standing at the 30, O is now the 1 and H is now the 2. So sine of 30 is not equal to cosine at 30. But there is a repeat there. Sine at 30 is 1/2. And we did get a 1/2 when we were standing at 60. It just happened to be cosine of 60 to make that work. So, oh, sorry, let me go back and fix that. I see what I did wrong there. So I said, is sine of 60 the same as sine of 30? So sine of 60 was 1/2. Sorry, sine of 30 was 1/2. Sine of 60 was radical 3 over 2. Those were not the same. But if I switched it to be sine of 30 and cosine of 60, would those be the same? And the answer is yes. So what happens if I want to get the exact same things? I have to go and change the trig function to the one that uses the flip, basically. And then I also have to go to the other angle. So that's going to lead us over to this one, which is called cofunctions. Cofunctions are not the same as reciprocals. Cofunctions are how to get the same ratio or the same fraction. Okay, so if I want to find another way to get the same fractions as sine at theta, I'm going to go to the other angle and I'm going to do cosine from that angle. So tangent, if I want to get the same thing from tangent, if I go over to the other angle, which is just another way to say 90 minus that angle, if I go over to the other acute angle, then what would it be? It would be, let's see, tangent, if I go to the other one, would be cotangent. And then secant would be cosecant. Are you noticing a similarity when I name those? Sine and cosine go together. Tangent and cotangent go together. Secant and cosecant go together when we're talking about cofunctions. Okay, so cosine and sine go together. Cotangent and tangent go together. And cosecant and secant go together. Okay, so again, just to show you what we're talking about here. Okay, let's call this theta, and we'll call this one right here 90 minus theta. So the differences are between this person standing here at theta and another person standing up here at the other place, right? So if I'm the orange little stick figure dude and I want to do sine of 72, well, let's just start with a regular triangle where I give you the angles. So let's say that this one was a 3, 4, and 5 triangle. And I said, I'm this person right here in orange, and I want to know what is equal to sine when I'm standing where I'm at. Well, if I'm standing here, sine is 4 over 5. Okay, if I'm the other person, how do I get a 4 out of 5 out of that answer? So if I want to be the other person and get a 4 out of 5, it's not O over H, it's A over H. So I have to switch over to cosine to get those. Cool. That's why they're considered co-functions. So all you have to do for down here for 1, 2, and 3 is if they want a co-function, you just switch over to the co-function trig. So sine and cosine go together. Cosecant and secant go together. And tangent and cotangent go together. So it's just knowing what their co-functions are first. Then the second part is you have to subtract to get to the other angle. So that's 90 degrees minus whatever the angle is that they gave you. So 90 minus 72 would be cosine at 18 degrees. Secant at pi over 3, Okay, so pi over 3, 90 degrees would be half of 180. So that's going to be pi over 2. So I'm going to say pi over 2 minus pi over 3, which is another way to say 90 minus. And then I'm going to have to do ugly fractions. So this is going to be 3 pi over 6 minus 2 pi over 6. So this is going to be the same thing as secant of pi over 6. Okay, cotangent again with this. So we're going to have to do pi over 2 minus pi over 12. Get common denominator of a 12. This one would be 6 pi. That would still be 1 pi because it was already a 12. So we're going to get for this last one cotangent of 5 pi over 12 would be the cofunction. All right. All right, so right triangle trig, how do we find missing sides or missing angles? So for these, we're going to need our calculator because these are not any of those special triangles that came from special shapes. I can tell because I'm looking at the angles and there's not 45s or 30/60s. So first thing I want to do is I want to stand at the angle that they gave me or that they're marking. So I'm standing here and I want to identify the sides that are given and the side I'm trying to solve for. So my feet are always on adjacent and hypotenuse. So I have adjacent and I'm trying to find opposite. Then I'm going to go look through my SOHCAHTOA and figure out which one uses A's and O's, and that's tangent. So I'm going to write out the equation, which is tangent of the angle equals O over A. Before I grab my calculator, I want to solve for that missing letter. So I'm going to multiply both sides by 1. So now I'm going to get tangent of 61 equals A. All right, so now I'm going to go grab my calculator, but there's a problem here. So when you go and grab your calculator and you turn it on, we need to go and press the mode button. Let's see if I can do this right. Look at the mode button, and you want to make sure that that third line down says degrees. If it doesn't, you're going to move your arrow down to it and press enter. To get out of this, you're going to press second mode, which is quit. And now we're in degree mode if we're doing degrees. If they give us pies and we're doing trig, we're going to have to switch back over to radians to do those on our calculator. All right, so now I'm just going to put into my calculator tangent of 61 and press enter, and I'm going to round to the nearest tenth. They didn't tell us to, so that seems like a good place to go. So I'm going to call that 1.8. Okay. All right, for the other one, I'm going to go stand up in that upper corner. So that's a 34 degree. My feet are always on adjacent and hypotenuse. So the 13 that they gave me is a hypotenuse. The A that they're trying to get me to solve is an opposite. So if I'm standing at 34, I need O and H. That's sine. So I'm going to do sine of 34 degrees equals A over 13. Again, I want to get A by itself, so I'm going to multiply both sides by 13. And then in my calculator, I'm going to do 13 times sine of 34 equals A. Okay, keep in mind that I'm not going to be using, I'm not going to multiply that 13 by the 34. So we're going to go and do 13 times sine of 34. And I'm going to get 7.3 for A for this one. Ooh, go away. Okay, so A equals 7.3. 3. All right. All right, so applications. Sighting the top of a building, a surveyor, that's just somebody who's looking through a scope on the ground, right? So they're looking at a building, okay? And they are looking at an angle of elevation to be 22. However, they are saying that the camera is above the ground. So what I really have is 2 parallel lines that are parallel to the ground. So the angle of elevation is 22 degrees. That's where the camera is or where the person's eyes would be. And they said that's 5 feet off the ground. And they want to find the height of the building. So I know the building is going to be whatever that side is of the triangle plus the extra 5. All right, so they also told I'm 300 feet the building. So on the triangle, that's the horizontal part. All right, so what trig function uses those? That's going to be O and A. That's tangent. So tangent of 22 equals x over 300. So multiply by 300, and we get 300 tangent of 22 equals x. I'm going to put that into my calculator, and then I'm going to add 5 to it. So 300 times tangent of 22 is 121.2 plus the extra 5 for the height is going to be 126.2 feet tall. So that's how we think how tall the building is, okay? In the second one, we have a building that's 21 feet tall that casts a shadow. So remember, you don't see shadows floating in the air, people. They're on the ground. So this part right here is 25 meters. And they said the angle of elevation is what they're asking me to find. So angle of elevation is always from the horizontal up or from the horizontal down if it's depression. And they said that it is a 21 meter. So what trig function uses opposite and adjacent? That is also a tangent. So I'm going to do tangent of theta equals 21 over 25. Okay, so to get this one by itself, I'm going to have to remove the tangent. That's not reciprocal, that's not cofunction. To remove it, you're going to do inverse tangent of 21 over 25. And inverse tangent is on your calculator right